Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to find the binomial series for this function 1 over 1 plus x square centered at 0. And we have to use the power series representation of the function 1 plus x to the k. So this is the binomial series given for the general function of the form 1 plus x to the power some number k. And our function is 1 over 1 plus x squared. So first, let's see if we can rewrite this function expression in this form, the left hand side, and then we can write down the actual power series. Okay. So function is 1 over 1 plus x squared. But in order to apply this power series, the function should be in the numerator, but our expression is in the denominator. So of course we can bring it in the numerator, and using the properties of exponent, what happens if you bring it in the numerator? The 2 is actually negative 2. And now look, this looks like 1 plus x to the power k. So this is like 1 plus x to the power k, where k is negative 2. So we take the expression for the series and plug in k equals negative 2, and we will get the binomial series for our function. So let's see. So 1 plus x to the power negative 2 will be equal to, so the first term is 1. Second term, we have k times x, but k is negative 2. So negative 2 times x. Then we have negative 2 times negative 2, negative 1 over 2 factorial x squared. And then continue. Fourth term, negative 2 minus 1, negative 2 minus 2 over 3 factorial x cubed. Let's write down one more term, and that will be negative 2 times negative 2 minus 1 times negative 2 minus 2 times negative 2 minus 3 over 4 factorial x to the 4, and then you continue because this is an infinite series. Okay, so now let's see if we can simplify this a little bit, and if we can look at a pattern and write down this whole series in the sigma notation. Okay, so let's see. Be careful with the signs. You see there's a negative sign for this term, so negative 2x. For third term, you see we'll have a negative and a negative, so it'll be positive. And in the numerator, we'll have 2 times 3 over 2 factorial x squared. Okay. Then in the next term, see there are 3 factors, and all of them will be negative, so we'll get a negative. Numerator will have 2 times 2 plus 1 is 3 times 2 plus 2, 4 over 3 factorial x cubed. Then again we will have 4 terms, so it will be positive, so I did write correctly, and then 2 times 3 times 2 plus 2, 4 times 2 plus 3, 5 over 4 factorial x to the 4, and go on. Okay, can we simplify anything? So 1 minus 2x remains as it is. Now look at this third term. We have 2 times 3. Do you notice that that's actually 1 times 2 times 3? So that's actually 3 factorial and divided by 2 factorial. Now 2 factorial is 2 times 1. And so, as you can see, this 2 factorial will cancel with the 2. And we'll be left with plus 3x squared. Okay, let's look at one more term, right? 3 factorial is 3 times 2 times 1, right? So 3 factorial is canceling with the 3 and the 2. And we'll be left with 4x cubed. Okay, one more term. Let's see if it works, right? 4 factorial. And see, 2 times 3 times 4 is 4 factorial. So this entire thing will cancel. And then we'll be left with 5. x to the 4, and then it looks like, see, we have an alternate positive and negative sign. Do you see that? First positive, then negative, positive, negative, and so on. So since this term is positive, the next term will be negative. So this was probably not quite correct. It was negative. And then we go on. Okay, now can we rewrite this whole thing using the sigma notation? Okay, so look at the terms, right? We have 1, then 2x, then 3x squared, 4x cubed, 5x to the 4th. Okay, now 1 corresponds to n equals 0 usually, right? We start with n equals 0. And then we have the numbers. If you look at the numbers, for n equals 1, we will get 2. So let me write this down. This is for n0. This is for n1. And then n is 2. Okay. So how do we write 2 in terms of 1? Well, if you write n plus 1, right? This is 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. So we'll probably have an n plus 1. Okay. Now what about x? For n equals 1, x has a power of 1. Then n equals 2, x has a power of 2, and so on. So we'll have x to the n. Okay, but that should not be enough. How do we write down this alternate positive negative sign? Do you know what will give us alternating positive and negative? Well, there should be a negative 1 component to it. And notice that if we have a negative 1 to the power n, and then what will happen? When n is even, you get positive. When n is odd, you get negative. So whenever you have an alternate negative positive, you will always end up having a negative 1 to the power n or n plus 1 in your expression. Okay? Just check. For n equals 0, we need to get a positive, and we get a positive. For n equals 1, we should get a negative. So we're good. So let's write it down one more time. N from 0 to infinity, negative 1 to the n plus 1, x to the n. So in the sigma notation, if you want to write this series, this will be the expression for the function 1 over 1 plus x whole square. Thank you.